Let's see. Hmm. Okay. Green record. Sorry, let's see. Yeah, good afternoon, Charles.
Good afternoon.
I hope you're doing good.
Yes, I am doing good. Thank you.
Oh, yeah. Okay. So just give me a minute. I'm coming. But before then, I presume like you've checked me out, like you've gotten, let's say, a bit of information about me on LinkedIn. But still, let me just do a bit of, let's say, introduction. Nothing official, just a little bit. So I'm a DevOps engineer, and I've been a DevOps engineer for 3 years plus, going to 4 years. And
Wow.
I've been able to work with startups, enterprises to help them, deploy applications, provision infrastructures, and basically streamline their whole processes. So yeah, that's a bit of it. Started from software development background. I didn't stay there for too long, but at some point I moved into DevOps and cloud space, right? So and we've been there since then, learning and learning, building projects and becoming better, basically. So yeah, that's a bit about me. And another thing is, okay, I among many things I enjoy teaching, or would I call it mentoring? Yeah, something like that. So yeah, I think that's a bit about me. How about you? I'd love to hear from you.
All right.
Maybe
Thank you for the
right.
introduction. And Charles, the backend engineer who just is switching to DevOps. I started learning DevOps in December, so I was able to cover the fundamentals and just got introduced to the cloud, and that was this month. Yes, so that's me. Thank you.
All right, that's nice. All right, give me a second. Okay. Mm, So, Kevin, so for this what you asked for earlier, just give me a minute. I'm trying to get the original image on my
Okay.
system. All right. All right. Let me try this. All right. Let me see. So I would just basically share my screen now. Just a minute. Why is it not coming up? I shall just share the entire screen then. So I think you should be able to see my screen now. Yeah.
Yeah,
Right.
I can see it now.
All right. So I just had to look for this because I have a couple of them. But is I'm not sure the one you saw was exactly the same as this, but the whole concept is still the same basically, right? So if you take this for instance, right? It looks like a lot, but it's not actually a lot. It just takes understanding each concept and how they connect together. Right? At first, it looks like a lot, but if you take the time to go through it over and over and over again, you'll see that it gets more simpler by the way. Okay. So what we have here basically is an architecture, right, of of how a dynamic web application is deployed in a 3-tier architecture. So since you said you just what's the word now? Entered into the DevOps space, that's like probably like a month or 2 months now, probably. So, uh, wow, it actually it basically means right that there's still like a lot to learn to be honest, because it requires time to really understand a lot of concepts. But yeah, this is an architecture, right, of how a dynamic web application is being deployed in a 3D architecture. Let me see if I can. I think we should. My let me on my camera. If it's giving me issues, I would off it. Okay. Others might still see the. All right, let me go ahead. All right, so over here now you can see the three architecture you're talking about here is this. We have this is the first tier, second tier, and third tier, right? That's how it's that's all the three architecture means. So there are different type of architectures actually. There are about I think like about 5 different kind of architectures, but one of it that we have in this particular use case is the three-tier architecture. So there are a lot of architectures. I don't want to go into that, but this is the three-tier architecture where we deploy a dynamic web application. So um, okay, let me just explain a few. So because it is a dynamic web application, you know, it means I think from your experience in software development as a backend engineer, you understand that if something is dynamic, it means that you you are receiving input and output like information backend, front end. There's information moving, right? So it means that you will need a backend. You need a database to store information and you can retrieve it, right? So that's why we have a database here. It was a static website that doesn't need you to store any data, like let's say an article, you just go there and read it. You don't need a database to store anything, right? Specifically. So, but because it's dynamic, we need a database. So, I want to start from the beginning. So the first thing we have here is the AWS cloud, which already shows that we are deploying our infrastructure, right? Our applications, everything on AWS. That's the first thing here. The second part of it is the region. So in AWS, we have a lot of regions, right? Multiple regions. And what that just means is that a region is where AWS servers are where they are around the world, basically. So you have different regions. You have the US East one. There are a lot of them. There are a lot of them, basically. So this is a particular region. In this case, I deployed this to it should be US East one. I also deployed it to another region also. But let's take US East one for example. Then we have inside that region, we have okay, before that, you actually choose a region based on the location that is closer to your customer so that they can easily access your services. They call it low latency, right? Uh, But I really believe that you understand some of this concept because you came from a software development
Yeah, I
background.
understand.
Yeah. So that's the region. So ideally if your users your users are, let's say, in the United States and in India, you would choose regions. You choose one region that is closer to the United States, which is one of the region is US is one. Another region that's closer to India. I don't know that region, but if I go on the AWS, what do you call it, platform, I can find it, right. It just depends. That's why you need regions, right? You choose where your customers are and you deploy your applications there. Basically, you are deploying your applications in a data center that is around that area. So that's it about the region. Coming to the virtual private cloud, it's basically, the cloud is basically servers, right? Big servers, basically. Let me put it that way. Servers that can do high computation, right? More than just our laptops and our desktops, right? And on those servers, because a server can have, like, let's say, let me even think of it. It can have, like, let's say, a memory of 1,000 gig or something like that, terabytes, things like that. Very, very large, right? So our VPC is all saying that we want to create our own space with cloud, right? Because a lot of customers, a lot of organizations have their application deployed on AWS. So a virtual private cloud is the way you separate your own infrastructure. That this is my own private space in the cloud. Simple, right? And for you to do that, you need something called a cider block, which is what is here, 10.0.0.16. I won't dive into that because that's about networking. But that's basically how you define your space in the cloud. Simple. So the next thing you can see here, this blue line is called availability zones. So in a region, you have what you call AZs, availability zones. You can see I have AZ1, AZ2 here. So let me explain what that means. So it means that in a particular region, let's say in the sorry, let's say in a particular, let's say in the, let me use Nigeria for instance. Let's say in Nigeria, because I don't think there are a lot of data centers in Nigeria, but let me just say Nigeria for our use case. In Nigeria now we have, let's say in the north in Nigeria, right? That's a region, right? You can call it Nigeria North, for instance. Then in that region, because the north is a big place, the same thing as west, east, and south of Nigeria. It's very big. So in that north now, let's say in Kaduna, in one state or the other, they are now you can now have availability zones in those places. So it just means that, let's say in Kaduna and Kano, for instance, now there are data centers in Kaduna and Kano, right? It's still within the north, but they are in different locations. And the reason why WS watch is like that is because it want if by any means there is, let's say, any issue, or let's say any disaster, because over there, there's a lot of disaster that can happen. Let's say hurricane, anything can happen and affect those data centers. So the idea is that if the one in Kano is affected, the one in Kaduna will not be affected. That kind of thing. So your application can still be routed to the other one. That's the idea of availability zone. So that's why we have two here. It's for high availability, such that if this one go down, this other one is still available. All right. I think okay. So now we can now go into, let's say, the 310 now. And in this 310 we have the public subnet, the private app subnet, and the private data subnet. So in the public subnet here is basically you put services that you want those services to have direct access to the internet, right? Yeah. So that's where we have something we call our Bastion Host, also called a jump saver. Basically, what this does is that you use that saver to be able to securely access your application in this private subnet, right? Because the idea is that, yeah, the resources in your private subnet, you don't want them to have access directly to the internet. Neither do you want your users to have direct access to those services in these private subnets. They are very sensitive, they are critical. We don't want anything to affect them, so we keep them in the private subnet. So you can use the Bastion node that is in the public subnet to securely access what we have here. That's number one, right? There are other ways to do it also. You can use what we call an endpoint service that we have here to securely access your private subnet also. So that's the idea of this Bastion node. It's also called jump saver. I hope I'm not too fast. I may be.
No.
All right, okay.
But why is the Bastion host not in the availability zone B?
Yeah, right.
Yeah.
Uh, there's really no reason, in quotes, you can have it here, right? You can have it here. Yes, you can have it here.
Okay.
I the reason why it's not here in this design, in this architecture, is just that, when you're provisioning resources on AWS, every resource has an expenses. So I didn't want to provision it here also. But I can just put it here. There's no big deal about that, right? It means that Bastion knows that is here will be able to communicate to this. We'll be able to use that to access what we have here basically. So is you can add it here. There's no big deal about that. I didn't just put it here because in the implementation I only had it here basically. So for the NAT gateway, yeah, I think this is where something gets very interesting. So for the NAT gateway that you have here, NAT gateway is just basically a service that AWS provides that allows that allows you to that allows the resources in your private subnets, right, which is your databases and your app server or your web server in this case, where your application is deployed, to be able to um, access the internet but not directly, right? To access the internet, right? Like this internet here, but it's not going to access it directly. So that's what NAS Gateway does. It allows the resources in our private subnets, right, to be able to access the internet, but not directly. So why do we want the resources in our private subnet to access the internet? There are a few reasons, right? Let's say in your server here where you deploy your application. Let's say because there are various instances. There are, I will take a particular use case now. So let's say we are trying to deploy a PHP application, right? That was built with PHP. In that case, you know and you understand that if that's the case, we need to for a PHP application to run, it needs some PHP dependencies, right?
Yeah.
If you know that, so you need to like install some PHP dependencies and all of those things. So those things for you to install them, the source of those things that you want to install are in the internet. So for you to install them, you need to have access to the internet to install those resources, those dependencies that will make your application run effectively. So for you not to access the internet, you don't want to access it directly. So you use the NAT gateway, right? The way Okay, let me now go back here. The way this public subnet accesses have direct access to the internet is through this what we call a NAT gateway. That's what it does. So the NAT gateway is how the resources in the public subnet have direct access to the internet. But in No, that's internet gateway, if I'm not mistaken. But the
Yes,
NAT gateway,
internet gateway.
yeah, NAT gateway is a service that allows the resources in your private subnet to have access indirectly to the internet, because we don't want them to directly access the internet, because our end users we don't know who our end users are. We don't want them to just have access to our physical resources, right? So that's what this does, to allow these services here to have access to the internet but not directly. Why this allows resources within our public subnet to have direct access to the internet, right? So, uh, yeah, so that's why we have a NAT gateway here and here distributed, and then we have our webs, our I should have called them app servers, right? So we have our app servers here, where our app is deployed, and then we have your database basically. Because if you look at the connection from here, the database, you see that our app server needs to be, storing data basically, and also communicating with the database over here. So that's why you see the arrows pointed here. So, and you can see the arrow from this master. You can see master database and the standby. So why do we do this, right? This is the main database. Is now basically replicating data into this one that is over here. So let's say if this goes down, we already have our data here, and from this data that we have here, we can create a snapshot. A snapshot is just like, let's say you create, how do I put it now, a snapshot of it. You can use that snapshot to create another database if this goes down by any means. So that's why we have two ACs for redundancy.
Snapshot is like backup.
Yeah, you can call it backup. Yeah, so you can use that data to launch another um, database, right? And everything still keeps going on. So that's about this. So you have an availability. So like you have this is called an auto scaling group here. So what this does is basically saying that we want our application to be highly available, and for that, we want to be able to scale in and scale out depending on the use case. Let's say we have 1,000 users normally. Now we are getting 10,000 users. So our app server needs to be able to handle that request, right? And for you to be able to do that, we need to increase the number of servers that we need to have. So that's what the auto scaling group does. So let's say we can configure it to say that, let's say when our CPU utilization is about 80%, scale scale out. I mean, so you can deploy, let's say, more instances depending on the use case. You can deploy, let's say, 5 more instances to handle that 10,000 requests. So, and let's say if our traffic from our user reduces to 1,000, it shrinks back to 2 EC2 instance. So that actually helps to reduce cost and makes everything very efficient and highly available. So that's it about this auto scaling group. Now we can talk about this application load balancer. So load balancer, the name says, and probably from your experience, it basically balances load across different app servers, basically. So traffic is coming from our end users here, right? I will explain this later. From our end users here, and reaching our NAT gateway, internet gateway, sorry, and then it's in our load balancer. So the load balancer receive the request and route those requests, right, to the app servers, right, based on different algorithms. You can route to those particular app servers to make sure that the load is balanced. That one server is not having a lot of load, while another one is having less load. So it balances the load. So actually, it does more than that, but that's like a main function. It does more than that. It does what do we call it? It stands for security. Let's say our user that is accessing this application is somebody that is accessing it in a very like an hacker, basically, right? Trying to perform, like, let's say, SQL injection and all those cyber attacks. We can configure this with another service called WAF for security, basically. But that's really what this does: load balancing in simple terms. And here we have what we call Amazon Route 53. So this is just a service that does DNS resolution. So what that means in simple terms is that if your domain name is google.com, every domain name has an IP address. So what it does is that it resolves that domain name that users type on the browser to an IP address, right? So simple.
Okay.
Simple. So I think I've talked about this endpoint service. It's a way to also access your private resources or your public resources too directly without using things like SSH keys. I think I explained that in my last post on. No, wait. No, that will be tomorrow. Okay, not yet. I think that's that. Then few things that we have here. Secret manager is on is basically for storing our secret. Let's say our database password and username, things like basically secrets. Any kind of secret you can store it there and retrieve it at runtime, right? Depending on how you want to do it. So, and this certificate manager here is simple. It gives you what do you call it now, SSL certificates, right, to make your website secured. So your website can have that S at the back of the HTTP secure website. So use the certificate manager to do that. And then the AMI here is simple. This one is used when we are trying to. It's used. This is going to be used for this auto scaling to happen, right? So what is AMI? AMI means Amazon Machine Image. So what we are using it to do in this case is that when we've deployed our application to our app server here, right? We are going to extract an AMI from it. So an AMI just means like what say, let's say what would I call it? An image from it of what's exactly going on within the server. We are going to extract it. So is that image that the autoscaling group will use when it launch another instance. It will use that image into that instance, such that when the instance come up, anything that what is here that what was here exactly is what will be in that new instance. I don't know if that makes sense.
That makes sense. Yeah.
Yeah, so that's what they use it. So you have to, for you to have an auto-scaling group, you have to have deployed your instance in a particular server and extract an AMI. So the AMI, you would obviously configure it in the auto-scaling group such that if you're trying to increase the number of server, that AMI is what you would basically, let's say, install in it. Then I don't need to begin to do all the installation from scratch again. Everything is just you just have my application running in a few minutes, right? So that's what this does. And then the S3 here, S3 is basically a service for storage. S3 means simple storage service. So for storage, you can store files, you can store videos, you can store a bunch of things right there. But for this particular project, we use it to store various things. We use it to store our code, right? Our code that we were deploying, like our application code. We use it to store a particular file called an app service provider file that was important for the application to run effectively. So what that file does is basically to route traffic from HTTP to HTTPS. That's what that file does basically. Now there was another file again, an SQL file that we used to that
Sorry,
SQL.
sir. Which one routes HTTP to HTTPS? Which file is that?
Okay, that file is basically an app service provider file. Like it's part of the particular application code. So the application code came with two files that we need to basically be able to run the application correctly. So it's just I'm just saying it's for this particular use case, not generally. Every application is different. So for this particular for this particular use case, the file that was stored here was the application code number one. Number two, we have the app service provider file. That file just basically helps you to route traffic coming from HTTP to HTTPS, right? Simple. So if a user types HTTP, right, which is not secure connection, he routes it to HTTPS. So it's the same thing that you would see in any. Let me look for something. Let's say, can you see my screen?
Yeah,
So I'm doing google.com now. Can you see this?
yeah,
But I'm not using this. I'm not using S. But
yeah,
Google has configured it in their system to route it to the secured one. So you will see what we have now. Can you see that it's S that is there, secured?
yeah.
So that's in their system at the back end. They've routed that any traffic coming from HTTP should be routed to HTTPS. So that's what I was trying to explain basically. Mm,
What's the difference between the Amazon S3 and the databases, the RDS?
all right, all right, all right, all right. So um, they are both used for storage, right? Storing data, but there's a few differences between the two. So when it comes to Amazon S3 buckets, you can use S3 bucket to store, let's say, like the way you store things like files, videos, like these basic things that you want to store and retrieve anytime. But for the RDS database here, is in connection with your EC2 and is storing your data in real time, right?
Okay,
So as your users are using your application and they are they are requesting for information, let's say login details, different things that are happening. Let's say an e-commerce site now, you are trying to process. You add a particular product to your cart. It stores that, right? It tracks
okay,
that. That's what it does. So that's what RDS. There are different type of databases. You have the RDS, the MySQL, there is RDS, Postgres, different kind of. But that's what you use when you are trying to connect your app servers with this use case. So this is just for storing other details like file and all of those things. But the reason why we even store some of those things here, right? Because in other projects, right? Why uh, everything that we stored here, not everything everything. Majority of what to study, like the code, you do need to get up. That's the way it should be done. But this particular project is just to show another use case. Basically, the code here should can be in GitHub and you can pull it from GitHub, things like that. So that's like the difference. And then I think the last thing that we have here is this. So the AMI role, AMI means identity access management. So what that does is basically it's one of the ways to secure your resources on AWS. So let me explain. Identity access management. So it kind of manages, how do I put it? It manages your access based on your identity. So in the IAM, you can create, let's say, users. You can create groups. You can have a group of devs, and those group of devs will have a particular permission of what they can do. You can have a user, right? And you put a permission on that user on base what they can do. So it's called least privilege, right? So for instance, now in this particular scenario of this project, so we have our code here, right? Our application code. We have some files that we need to use. We have the app service provider file. We have the SQL file. That SQL file is what we use to we want to that SQL file is what we are going to export that SQL file into our database. It's just a file to define the schema of how our data should be stored. So what was I even saying that? So in that case, our 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 server needs to have a permission to be able to interact with S3 so that we can get that file from here into the server and into the RDS. So just a way of defining permissions on who can do what and what can do what. That's just a simple way to talk
okay.
about it. Yeah.
Now,
So You have a question?
Yeah, for the public subnet and the private subnet, I can see a
Yeah.
padlock on the green ones
Now see
and
what?
padlock on the public subnet.
Yeah.
It's locked. Shouldn't it be open, whereas the private ones be locked? Something like that.
Okay. Okay. So it's just this is just a way to, how do I put it now? The lock there is not, how do I put it now? When I'm trying to design this architecture now, that particular image you see there is what represents the public subnets basically. So the lock in it does not, how do I put it? Is not exactly, what do I call it now? It's not exactly a differentiator from public and private. It's what they do, not the image itself, right? So
Okay.
actually, it's what I've not actually noticed that. I just know that that's a public subject, and I understand what it does, right? So yeah, that's it. Yeah, that's it.
Okay. It's the architecture is clearer now, very much clearer than before. Thank
Mm.
you. How do you manage to draw? Okay, apart from having the concepts, is there any particular tool that you use to draw all of these lines, the short dashes? Uh,
Yeah. There are tools definitely. So the tools I use two major tools. Although the one I use for this particular one is Lucid Charts. You can check it out. Lucid Charts, yeah, or Lucid.app.
basic charts.
Yeah, is a tool that you can use for drawing architecture.
And you
And
did it from scratch?
yeah, from scratch. Yeah,
Wow.
from scratch. And that's why I can explain every detail of it. So even though right now I know of, like, I came across one currently. There are tools that can draw your architecture for you. Even as much as that is good, that's only best for people that already understand what's going on within the architecture. So I would advise that you start it from scratch. It will be stressful, but it will help you to understand what exactly connect to what and how things work. So
Okay.
yeah, that's it.
Thank you so much.
You're welcome.
So you've been in the DevOps space for about 4 years, right? I mean 3 to 4 years.
Yeah, 3 to 4 years.
Wow. Means you must be a senior engineer.
Uh, let's see. It depends. It depends on how you say it. I keep on learning. I would it just depends. I won't call myself a senior engineer, but like I have that mindset of a senior engineer. Let's do it that way. But you call it a senior engineer in the same thing. But I just see myself as, someone that has to just keep learning. So you have to just believe that, not believe, but you have to just understand that whatever you know, you just have to keep on learning. So you have to just kind of humble yourself and keep on learning, keep on building projects, keep on trying and figure things out. So that's how you learn and become better. So you can say that if you want to, but at the same time, you keep
But
learning.
I want to ask again, though, like what made you start learning DevOps? Like what made you start? Did you come from a developer background or something like that?
All right. I came from a software development background. Yeah. I started that on when I was on campus, right? So I started that, and I remember learning. Okay, I think I came across web development when I went to a particular class on campus, and just found interest in it. I and my friends were like, let's keep on learning this thing. Let's develop ourselves more. So we kept on watching different, videos to just learn more and try to be better at what we've learned in class. But at the point for me, right? At the point for me, I just found out that this what I'm doing is nice. I'm putting a lot of effort, but I feel like there is another space I'm meant to be, right? Just had that
Okay.
knowing in me. So I didn't know exactly what that was. I didn't know anything about DevOps. That's like about 3+ years ago. About probably 2022 or so. So I didn't know. I didn't know what exactly it was, but I just felt like there was something more. There's something more, and that particular thing would require my knowledge of software development. So I was taking it seriously at that point. So after a while, reaching out to different people, on I just talking to them, people that I respect on campus. Then, so one of those days, I called one of my He was my president at that point in time. I called him and I was talking with him, and because he was already in the job market then, he was working. I think he was a software engineer then. Yeah, kind of. I called him and we're discussing, and I was just discussing with him, just checking up on him, and we're just discussing. Then at the end of his discussion, he mentioned DevOps, and I was like, DevOps, DevOps, DevOps. Okay. And I checked it out on Google, and I saw the definition of DevOps. I just knew that was what I was supposed to do. I just knew. Or just a
Amazing.
name. I just knew, and from then I started looking for ways to learn and all of that, and the rest is actually history. But that's the way I got into DevOps. Yeah.
Okay, so since you've got into DevOps, with this your experience, like you're also in the job market now, like since you work with about 4 companies, about 5 of them.
Mm-hmm. You
Sorry,
said
did you get
what?
my question?
No, no, I didn't get your question.
Okay, I said uh, since you've been in the DevOps field for some time now, are there still more opportunities for us who are still coming up, or
Hmm. Okay. Definitely, there are opportunities. There would always be opportunity. So I think I get where the question is coming from, and okay, I think I will be having a session like that too, a discussion like that. But there is opportunity. There are opportunities. You would look online and see a lot of jobs and all of those things. The thing now is that the market has gotten more. Let me use the word. I don't want to use the word tougher, but let me use the word tougher, right? Such that you need to now understand and know your craft properly. Just look at how I explained this architecture to you and broke down everything, right? There are
yeah,
engineers that cannot do this. Yes, I know engineers that cannot really they do it. They can't connect the dots together. They just know what this does. They are focused on two. So you need to now understand your craft very, very well, like be very good. And then as also you need to what's the word, show what you are doing, put yourself out there, right? Kind of let people know what you are doing, because nobody will know. You will never know I have this knowledge if I don't make a post on it or share it and all of those things. So
yeah,
those are like few things that you need to do if you are coming into the space, because right now there's a lot of there's this AI of a thing that everybody is talking about. There's so much noise everywhere. So yes, true. Be honest, AI is improving drastically. I'm telling you. I use it every time. Not like every time, but like when I want to like research and solve something, I use it, yes. But I understand what I'm trying to do. So you need to really understand the fundamentals, what is connecting. So what is connecting to what, how is this going to this, like some details, you need to understand them properly so that when you come to the field, right? Or when you're trying to look for offers and you probably have an interview, when you're explaining concepts, you person can perceive that you understand what you are saying. Like
yeah,
you have an understanding of what you are saying, and you have the fundamentals, because even some interviews will just ask you a simple question. They won't ask you any architecture, just ask you, if you want to do this, how do you go about it? Or let's say if you just ask you a simple question, right? And then if you don't know it, or let's say they'll ask you about networking, a simple question on networking, or a simple question on Linux, or what particular command or what particular tool in Linux you use to check for the processes that are running, and you're like, how do I know that? And that has put them off already, because that's what some company does, not all, sure, but some, and that's what big tech also do, which I've had experience with. Big techs do that. Big techs don't ask you big questions, just ask you simple questions, like basic questions, fundamental questions. That's the way they test if you really understand or if you really know what you are really doing. So what I would say is that number one, you need to learn and be very, very confident in your craft very well. Obviously, it will take time, but it's something that a journey that you can start. Number two is that you need to share what you are learning, what you are doing. Right? There is this mindset that I don't know so much. I just started my journey. That's not the right mindset. No matter what, this is the mindset that me I adopt. No matter how small you think, no matter how small what you think, what you think is very small. Someone else does not know that. Like what you know now, what I've explained to you today now, someone else does not know this. And if you come and
yeah.
share it with you, you will feel like, wow, you have actually helped me. So nothing in itself, nothing in itself is sorry. Okay. nothing in itself is small enough, bro. Nothing in itself. Just need to understand that somebody else is has not even started their journey in DevOps, and I have a little bit of knowledge I can give to them. So that already makes you valuable. So share your knowledge in LinkedIn. It's very stressful, to be honest, yeah. And you have to. What I do personally, right, is this. I I don't share content just randomly, no. I share content that are valuable, number one, and from my own experience. So when I'm building project, I found something very insightful. I'll share it. I'll just create the content on it and share it. So that way, I'm not thinking of what to share. It's something coming out of my own experience. And secondly, um, I'm also learning, right? What I'm sharing, for me to communicate something to you, I need to understand it. So it also makes me understand what I want to communicate. So those are the
Oh,
few things I would say in coming to job market, because I've seen a lot of crazy things in the job market too. A lot of crazy things. But if you have the opportunity to work with startups too, I think you can take advantage of that. But at the same time, it's a lot of responsibility that comes with startups because you'll be the main engineer. So that's just actually it. I can say, yeah, that's it.
okay. So my last question, like, um, what's the opportunities similar to the other one in working with these companies from Europe? Like, as I'm just starting out, is there a lot of hope for me, or I have to grind and grind and grind and grind? If I want to
Okay,
work with Europe companies, yeah,
okay. You are saying that working with is it Nigerian companies compared to companies abroad? Is that what you mean?
yes,
Uh, no, it is just the thing. When you are trying to find opportunities in Nigeria, you are largely competing with people within this ecosystem. But when you are talking about looking for opportunities abroad, you are competing with a larger audience, and at that point, it's more tougher. Yeah, it is. It is. It's more tougher. So there's not. How do I put it now? I think as a starting, I just start with something that you can get your feet into the system first of all. You can start with a Nigerian company, at least get your feet into a particular system, get some experiences that you can say I've done this right, and that will build up over time. Because if you are just at this beginning stage, if you are looking at getting a company abroad, it can be very tough. It's not impossible, but it's very tough because there are a lot of people already on ground that have been laid off that have enough experience are looking to get to that place. So that's really it, right? Just start and keep building. Start and keep building. You will just look in the next 2 to 3 months what you'll be able to learn and all of that.
all right. Thank you so much.
Yeah, you're welcome. So I think that's it, right?
Yes, please.
All right, all right, all right, all
Thank
right.
you for your
So
time.
you are highly welcome. You're highly welcome. One more thing let me see. I want to share. One more thing I want to share is sorry, is that I'm coming. Just give me a minute. Trying to get
Right.
some. Tip, 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 tip. So currently, I'm saying, um, all right. Yeah, so what I wanted to do. Let me share my screen. Yeah, so currently I'm putting together because I see that a lot of I can see a lot of people coming into the space of DevOps and cloud, right? And through my experience, I know how difficult it can be, right? Trying to get your foot. A lot of mistakes that people make. Some of them are trying to chase tools and not understanding systems. A lot of issues, a lot of mistakes, right? So one of the ways I personally want to work around that to help people is what I'm currently doing, right? I'm putting together a boot camp, right? Let me
Okay.
show you. Show you. Yeah, yeah, this is it. I'm putting together a boot camp, and this is going to be a lot of work on my end because it's going to be a lot. I've put together a boot camp that would help, and I've created a lot of projects, a lot of tools that we're going to learn. So this is something that I've worked on and I'm still working on basically, right? To help people come in